Hello kids, I'm teacher Rodeline and we are now on module 2 quarter 3 in our math grade 6. Our topics for today, formulating rules in finding the nth term and differentiating expression from equation. After this module, you are expected to formulate the rule in finding the nth term using different strategies like looking for the pattern, guessing and checking, and working backwards. Also, you're expected to differentiate expression from equation. Okay, let me see if you can still remember about this topic. So you are going to supply the next three letters, figures, symbols, or combination of numbers and letters in the following patterns. So as you can see, number 1, it is a combination of numbers and letters. So the numbers are it is in ascending order 2, 3, 4. So the next should be 5, 6, and 7. Letters are A, B, C. So the next three letters are D, E, F. Therefore, on the first blank, it is 5D, 6E, and 7F. For number 2, the numbers are in ascending order. It is a multiple of 2, or each number, each term increased by 2. You can 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, 10 plus 2 is 12, 12 plus 2 is 14. Number 3 is same. The numbers are in ascending order and it also increased by 2. 5 plus 2 is 7, 7 plus 2 is 9, so 9 plus 2 is 11, 11 plus 2 is 13, 13 plus 2 is 15. Number 4, letters are Z, Y, X, W. Therefore, same Z, Y, X, W, or W, X, Y, Z, W, X, Y, Z. Number 5, without a number, Z without an exponent, that means 1. So the exponents are in ascending order and it increased by 2. So 1 plus 2 is 3, 3 plus 2 is 5. Therefore, our base same as Z, but 5 plus 2 is 7, 7 plus 2 is 9, and 9 plus 2 is 11. So base are all the same as Z. Okay, for this activity, we're going to blacken the thumbs up icon if the statement is true and blacken the thumbs down icon if the statement is false. Okay, number 1, expression is a phrase, so it is true. Number 2, equation is a sentence, so it is also true. Number 3, equation has an equal sign, so it is true. Number 4, equation has two sides, left and right. For it is an equation, it has an equal sign, so it is true. 5, expression has two sides, left and right. Since it is already the equation, so it is not an expression, so it is false. Okay, let us try to find out why we come up with our answers a while ago. So we have here finding out the nth term rule. So we have the meaning of sequence. It is a set of numbers written in a special order by the application of a definite rule. Each number in a sequence is called a term. Now we have here example number 1, the sequence 7, 10, 13, and 16 consists of 4 terms. If you are going to find the next 3 terms, it will be 19, 22, and 25. Now, let us try to find out how we come up with these next three terms, 19, 22, and 25, by following the steps. To find nth term rule, we have these steps to follow. Since the given sequence is 7, 10, 13, and 16, step 1, we are going to find the difference of the numbers. So from 7 to 10, it is added by 3. 10, it becomes 13. So again, plus 3. 13 to 16, again, plus 3. So 3, or we will write 3n. N is a counting number, or let us say multiple of 3 times n. So when you say counting numbers, it is a set of numbers from 1, 2, 3, and so on. Now, if n is equal to 1, so it is 3 times 1, so it is equal to 3. If n is equal to 2, so it is 3 times 2, so that is 6. If n is equal to 3, so that is 3 times 3, so product is 9. If n is equal to 4, so 3n, or 3 times 4, is equal to 12. So step 3, working backwards by subtracting the products by the given sequence. So our products before are 3, 6, 9, and 12. If we are going to subtract 7 by our product 3, we come up with 4. And 10 minus the product 6, again, the result is 4. 13 minus the product 9, the result again is 4. And 16 minus the product 12, the result is 4. So this time we're going to write plus 4. Before we have the 3n, and we're going to add plus 4. So our nth term rule this time is 3n plus 4. So this is now the pattern. If all the products will be added by 4, we can get the given sequence number. Like 3 plus 4, that is 7. 6 plus 4, that is 10. 9 plus 4, 13. And 12 plus 4, 16. So the sequence is 7, 10, 13, and 16. Okay, to check our answers, let us substitute counting number to n. Since our nth term rule is 3n plus 4, let us represent n with our counting numbers 1, 2, 3, 4, and so on. So if n is equal to 1, 3 times 1 is 3 plus 4, that is 7. If n is equal to 2, 3 times 2, 6 plus 4, that is equal to 10. If n is equal to 3, 3 times 3 is 9 plus 4, that is 13. If n is equal to 4, so 3 times 4 is 12 plus 4, that is equal to 16. So the sequence 7, 10, 13, and 16. Remember that our nth term rule is 3n plus 4. If we are going to find the next three terms, we have, if n is equal to 5, so 3 times 5, that is 15, plus 4, that is equal to 19. If n is 6, so 3 times 6 is 18, plus 4, that is 22. If n is 7, 3 times 7, that is 21, plus 4, that is 25. So the sequence 7, 10, 13, and 16 with the next three terms are 19, 22, and 25. Our first example is in ascending order. This time, let us have a sequence in descending order, like the given 22, 19, 16, 13, and 10. The next three terms are 7, 4, and 1. Let us try to find out how we come up with 7, 4, and 1. And also, let us try to determine how we come up with the nth term rule, negative 3n plus 25. Remember the first step that we are going to find the difference of each term. So 19 minus 22 is negative 3. 16 minus 19, that is negative 3. 13 minus 16, again negative 3. And 10 minus 13, negative 3. So we will write negative 3n, wherein n represents the counting number. We come up with these multiples of negative 3 following the term or expression negative 3n. So if n is equal to 1, negative 3 times 1, so we have negative 3. If n is equal to 2, negative 3 times 2, that is negative 6. If n is equal to 3, negative 3 times 3, that is negative 9. If n is equal to 4, negative 3 times 4, so the result is negative 12. If n is 5, the negative 3 times 5, the product is negative 15. So step 3, working backwards by subtracting the patterns or subtracting the products from the given sequence. So if you're going to subtract 22 and negative 3, so the result is 25. Again, 19 minus negative 6, that is 25. 16 minus negative 9, the result is 25. 13 minus negative 12, the result is 25. And 10 minus negative 15, the result is 25. So we can write positive 25 or 25. Could be plus 25. So the nth term rule, before we have the negative 3n, and we will add the plus 25. So finally, negative 3n plus 25. So to check, let us try if n is 1. So negative 3 times 1 is negative 3 plus 25, that is 22. So if n is 2, negative 3 times 2 is negative 6. Negative 6 plus 25 is equal to 19. If n is 3, negative 3 times 3, that is negative 9, plus 25, it is equal to 16. If n is 4, so negative 3 times 4, that is negative 12, plus 25, the result is 13. So sequence 22, 19, 16, and 13. This time we can find the next 3 terms using our rule. Our nth rule is negative 3n plus 25. So remember that our sequence is 22, 19, 16, 13, and 10. And let us try to find out what are the next 3 terms. So if n is equal to 6, negative 3 times 6, that is negative 18. Plus 25, the answer is 7. If n is 7, negative 3 times 7 is negative 21. Plus 25, the answer is 4. If n is 8, so negative 3 times 8 plus 25. So negative 3 times 8 is negative 24. Plus 25 is equal to 1. So the next 3 terms after 22, 19, 16, 13, 10 are 7, 4, and 1. This time our next example is on fraction. So given sequence is 1/6, 1/10, 1 over 14, 1 over 18. The next three terms are 1 over 22, 1 over 26, and 1 over 30. So let us try to find out why we come up with that answers. And also let us try to determine how we arrive with the nth term rule 1 over 4n plus 2. Now step 1, we are going to find the difference of the denominators 6 and 10, that is added by 4, 10 and 14, again by 4, 14 and 18, plus 4. So we will just copy the numerator 1. So all of the terms, the given terms are with a difference of 4. So we will write 4n or 1 over 4n. So multiples of 4. So we have 4, 8, 12, and 16. Just replace n by a counting number. 4 times 1, 4. 4 times 2, 8. 4 times 3, 12. And 4 times 4, 16. Step 3, again, we are going to work backwards by subtracting the products. Now, 6 is subtracted by 4, so we come up with 2. If 10 subtracted by 8, again, the answer is 2. 14 subtracted by 12, the answer is 2. And 18 is subtracted by 16, the answer is 2. So meaning to say, we will write plus 2. After 4n, we will write plus 2 or 1 over 4n plus 2. So by following our nth rule, which is 1 over 4n plus 2, we can compute for the next three terms. So if n is equal to 5, so 4 times 5, that is 20. 20 plus 2, that is 22. So that is equal to 1 over 22. If n is equal to 6, 4 times 6, that is 24. And 24 plus 2, that is 26. The final answer is 1 over 26. If n is equal to 7, 4 times 7 is 28. Plus 2, that is 30. So final answer is 1 over 30. So the next three terms after 1 over 6, 1 over 10, 1 over 14, and 1 over 18 are 1 over 22, 1 over 26, and 1 over 30. So what if the sequence or the given is 3, 9, 17, and 27? So the next three terms of this given are 39, 60, 53, and 69. And the nth term rule is n squared plus 3n minus 1. So let us try to find out how we come up with the nth rule and the three terms, the next three terms. So step 1, again, subtract the terms or find the difference. So 9 minus 3 is 6. 17 minus 9, that is 8. 27 minus 17 is 10. Since the numbers are not the same, we will subtract again. 8 minus 6 is 2. 10 minus 8 is 2. Now, if we have the second difference, instead of writing n only, this time we will write n squared. And divide the difference 2 by a constant number 2. In case our difference is 4, it will be again divided by 2. If it is 8, divide 8 by a constant number 2. But we have 2, so divided by 2, so the answer is 1. So it is now 1n squared. So we are now on step 3, and this time we draw a table. If n is equal to 1 and the sequence number is 3, so n squared or 1 squared, that is equal to 1. 3 minus 1 is 2. Now if n is equal to 2 and the sequence is 9, n squared or 2 squared, that is equal to 4. 9 minus 4 is 5. If n is equal to 3 and the sequence is 17, so n squared or 3 squared, that is equal to 9. 17 minus 9 is equal to 8. If n is equal to 4 and sequence number is 27, so n squared or 4 squared, that is equal to 16. So 27 minus 16, the difference is 11. Now let us find the difference from 2 to 5, that is added by 3. From 5 to 8, the same, added by 3. From 8 to 11, so added by 3. So this time we will write plus 3n. From 1n squared, we will add plus 3n and negative 1. So final term or nth term rule is 1n squared plus 3n minus 1. So this time let us check the sequence using our nth rule, which is 1n squared plus 3n minus 1. So if n is equal to 1, so 1 squared, that is 1. 3 times 1 is 3. So 1 plus 3 is 4 minus 1, that is equal to 3. If n is equal to 2, so 2 squared, that is 4. 3 times 2 is 6. So 4 plus 6 is 10 minus 1, that is equal to 9. If n is 3, so 3 squared, that is equal to 9. And 3 times 3 is 9. 9 plus 9 is 18 minus 1 is equal to 17. So if n is equal to 4, so 4 squared, that is equal to 16. 3 times 4 is 12. And 16 plus 12, that is 28. And 28 minus 1, that is equal to 27. So the sequence 3, 9, 17, and 27. Correct. Now, the next three terms, okay, if n is equal to 5, so 5 squared or 5 times 5, that is 25. 3 times 5 is 15. 25 plus 15, that is 40. And 40 minus 1 is equal to 39. If n is equal to 6, so 6 squared or 6 times 6, that is 36. 3 times 6, that is 18. 36 plus 18 is 54 minus 1, that is 53. And if n is equal to 7, so 7 squared, that is 49. 3 times 7 is 21. 49 plus 21 is equal to 70. And 70 minus 1 is 69. So, from the sequence 3, 9, 17, and 27, the next three terms are 39, 53, and 69. So this time let us have some definition of terms. A numerical expression is an expression that combines numbers and one or more operation symbols. So here 5n is an example of an expression. A variable is any letter or symbol that represents a number. So n here is an example of a variable. A constant has a fixed value that does not change. 4 and 16 are examples of constant numbers. An algebraic expression is a mathematical phrase that uses variables, numerals, and operation symbols. So 5n plus 4 is an example of an algebraic expression. An algebraic equation is a mathematical sentence with an equal sign, which shows that two expressions on either side are equal. So here, 5n plus 4 is equal to 16 is the example of an algebraic equation. This time, let us differentiate expression from an equation. So 7x minus 2, the quantity of 3x plus 14 is an example of an expression. It is a mathematical phrase which combines numbers, variables, and operations to show the value of something. It stands for a single numerical value. It has no equal sign. It is one-sided. While 7x minus 5 is equal to 19 is an example of an equation. It is a mathematical statement wherein two expressions are set equal to each other. It shows equality between two expressions. It has an equal sign. It is two-sided, the left and right. Then it is a sentence, while in an expression is a phrase. If we are going to compare it in English, expression is a phrase, while equation is a sentence. Using a Venn diagram, let us differentiate expression from equation. The expression has no equal sign, while equation has an equal sign. Equation must solve for a variable, while expression can be solved unless variable is given. Then equation has an answer. Common, both have variables, both have operations, and both have numbers. For letter B, we're going to connect each airplane to the clouds that corresponds to the correct nth term rule by using a line. So for number 1, we have 3n plus 1, because if n is equal to 1, so 3 times 1 is 3 plus 1, that is equal to 4. So the next term is 7. So if n is equal to 2, 3 times 2 is 6 plus 1 is 7. So correct. So, and so on. For number 2, we have 3n minus 9. So, if n is equal to 1, 3 times 1, that is 3. Then 3 and minus 9, so that is negative 6. If n is equal to 2, 3 times 2 is 6, and 6 minus 9, so that is negative 3. For number 3, we have negative 2n minus 3. If n is equal to 1, so negative 2 times 1, that is negative 2. So negative 2n minus 3, so that is negative 5. If n is equal to 2, negative 2 times 2, that is negative 4. So negative 4 minus 3, so that is negative 7. Next, we have 5n plus 5. If n is equal to 1, so 5 times 1 is 5, plus 5, that is 10. If n is equal to 2, 5 times 2 is 10, plus 5, that is 15. So next we have 2n plus 5. So if n is equal to 1, so 2 times 1 is 1, plus 5, that is 7. If n is equal to 2, 2 times 2 is 4, and 4 plus 5 is 9. So those are the answers. Okay, for this activity, we are going to fill the blanks with the correct answer. Now, number 1, what are the missing numbers in the sequence? 2/3, 3/4, 4/5, blank, blank, then 7/8. So as you can see, the numerators are in ascending order. 2, 3, 4, so it is 5, 6, then 7. Same as the denominators in ascending order. 3, 4, 5, so it should be 6, 7. And we have 8. So first blank is 5, 6. Second blank is 6, 7. Number 2, complete the pattern 20, 16, 12, and 8. Then as you can see, each number or each term decreased by 4. So 20 minus 4 is 16. 16 minus 4 is 12. 12 minus 4 is 8. So 8 minus 4 is 4. And 4 minus 4 is 0. And 0 minus 4 is negative 4. Number 3, how many members in the fifth troop? If the first troop has 8 members, the second troop has 10 members, and third troop has 12. So fourth troop, since it has a difference of 2, that is 14, so the fifth troop is 16. Which troop has 22 members? So since fifth troop is 16, sixth is 18, seventh is 20, so 22 is 8th troop. What is the common difference? So as I've said, it is 2. For 6 to 10, we are going to identify the given if they are expressions or equation. For number 1, 3k plus 7 is equal to 34. Since it has an equal sign, so it is an equation. Next, 3n plus 5. No equal sign, so it is expression. Next, 5m plus 2. No equal sign, so expression. Next, 2n minus 13 is equal to 9. Since it has an equal sign, so it is equation. The last one, 2n plus 5 has no equal sign, so it is expression. This time, for what I can do, you are going to answer this one in your module. Same as for assessment, you are also going to write your answer on the blank or write it after the problem. For this given, you are only going to identify if it is an equation or an expression. That's all for today, kids. Thank you and have a good day.